Hello everyone, welcome to another one of my Leetcode videos. In this video we'll solve Leetcode 692, which is top k frequent words. So we are given an array of words or array of strings and an integer k, and we need to return the k most frequent strings. The answer should be sorted by frequency, and if the frequency is the same, then we sort them by alphabetical order or lexicographical order. So let's take a look at a couple of examples. The first example is I love Leetcode, I love coding. So in this case, k is equal to 2. So if we construct like a frequency count, we'll see I appears twice, love appears twice, Leetcode appears once, coding appears once. And so the words with the top two frequencies are I and love because both appear twice. And since I is before love in alphabetical order, it's returned as I first and then love. Similarly, the second example, the day is sunny, the sunny is. In this case, k equals 4. So if you notice, the appears 4 times, is appears 3 times, sunny appears twice, and day appears once. And since we're only looking for the top 4, this is the output. If we were only looking for top 3, if k was 3, this would be this is sunny. So let's take a look at how we would implement this. So the first option, which is a naive option, is basically we compute the frequency count. So we basically loop through all of the words and we compute the frequency count. So we'll basically store it in the map of string and integer, and this takes on because we loop through each word and update this map. And after we do that, we basically just sort this map. So we sort the map by frequency. So we could just be using a tree map or whatever, and then we pick top k from the map. So if we analyze the time complexity of this option 1, you will find that it's going to be big O of n log n, because computing the frequency map is on, but then sorting is O n log n, and then this one is OK. So it's going to be n log n plus n log n plus k, and since n log n is bigger than n, it's basically n log n plus k, and we are assuming k can't be larger than n because the maximum you can pick is n, and so the output is going to be n log n. So, but if you look at the question, it challenges us to do it in n log k instead of n log n, and so how can we optimize it? So if we notice, since we only need the top k, we only need the top k sorted. We don't need to sort the entire map. So instead of sorting the entire map, what we'll do is we'll pick things from this map and insert it into something like a priority queue. And if the priority queue exceeds k, we'll just drop the element from the priority queue. So in this case, if you look at this example, our frequency map will look like I equals 2, love equals 2, Leetcode equals 1, coding equals 1. And then once we have this frequency map, so this is option 2, it's basically the same as option 1, but instead of sorting the map by frequency, we insert into a PQ with max size of k, and this is going to be O of n log k because we do n inserts and each one is log k, and then we pick top k from the priority queue, which is OK. So this will be n log k. So the way that will work is yeah, this is after we create the frequency map. This will look like this, and then when we insert it in the priority queue, we first insert I equals 2 in the priority queue, and then we check if the priority queue is greater than k. It's not, because there's only one item. So then we insert the next one. It's still not greater than k, so we keep going. The moment we insert Leetcode equals 1, the priority queue exceeds k. So at this point we remove the smallest element from the priority queue, because we know that it definitely won't make the final list since there's already k elements above it. So we remove that one from the priority queue, and then the last one is coding equals 1. The same thing, it exceeded k, so we remove it. And let's say the coding was like 4. So in that case, when we insert coding equals 4, the smallest element here would be I equals 2, because it's the one that or sorry, it will be love equals 2 will be considered smallest because it's lexicographically later, and so we want I equals 2 to win. So love equals 2 will lose because it has the smallest frequency count, and among the two it is it has lexicographically later, so it will get dropped, and we'll be left with this. And then once we pop from the queue, since we want most frequent first, we will pop from the queue and insert it at the beginning of the array. So I equals 2 will come out first, and then coding equals 4 will come out second. And so that way the most frequently lexicographically greatest one is at the start of the array, and you know and sorry, lexicographically smaller one is at the start of the array, and then followed by the rest. So let's go ahead and code option 2. So our first step is that we need to create a frequency map. So word to frequency is equal to new hashmap, and so now we just iterate through our words. If so we're gonna insert so if word doesn't exist, we default the existing count to 1, and then add 1. So this will insert word and increment the count. If that 1 already exists, we'll get that count, otherwise it will default to 0. So now we have our word to frequency. So next, the step is to insert it into the priority queue. So we need to create our priority queue, but we need to be very careful about our comparator. So we'll be just inserting the map entry in the priority queue because we already have it. So it's going to be an entry of string and integer, and then the most important thing here, so the first parameter is the initial capacity, and the second parameter is the comparator. So the comparator is going to be very interesting because we want to sort, since we want to remove the smallest one if the priority queue overflows, we need to basically reverse the comparator logic, right? So the final list has to survive. The final list we want is basically comparator.comparing. So it's going to compare by value, but reversed. So because we want the higher frequency to be first, and then we want to compare by by name if the values are the same. But since this is the one we want in our final list, but since we want the priority queue to behave in the opposite way, since we want to be able to remove the one that didn't make the cut, we have to basically reverse this entire comparator. And so maybe this is a better way to write it. And so this first compares by greatest frequency, and then this one compares by alphabetically, and then this one reverses it so that we have the ones we want to keep towards the end. And so now that we have this, we just loop through our map. So we loop through the entire entry set, and we say pq.add entry or just entry, and then if we find that pq.size is greater than or equal to or greater than k, then we just remove the item from the pq. And finally, we create our result list. So remember, we need to add it from the, and then we loop through our PQ. So remember, we need to add it from the, we need to add it every time we pop, we need to add it at the start because we want it in reverse order. So while the PQ is not empty, results.add 0, PQ.poll, this adds it at the 0th index, and then finally we return the results. And one thing here is that this one might need an explicit type. So the first type is basically the type of thing that we're going to feed it, and the second type is the thing that we want compared. I think that we want integer in this case, and then similarly over here we compare an entry by a string. So let's run this, run it. So yeah, this is inline, and it doesn't like this documentation. I have it reversed, so let me do something like that. I must have spelled this wrong. Oh, so pq.poll is going to be the entire entry, so we just want the key. Cool. So one thing here, I realized this is going to be actually log k, because each pick from the priority queue will actually rebalance the queue. So it's not just okay, but still that wouldn't make any difference since it's still smaller than nlogK. So when you add them up, it's still going to be nlogK. So let's try to submit it. And yeah, we got an accepted solution. So I hope you enjoyed this video. I'll see you in the next one. Cheers.